All right now, so we'll kickstart the topic of sum and difference. So today and tomorrow we will look at the sum and difference identities, which are listed here in the box. Now I would share with you how I get these identities memorized. So I would say everything here, they have something normal, something not normal. Like for cosine, okay. Something that's normal for cosine is that, well, if it's cosine, so you start with the cosine A and cosine B, that's normal, okay? But then what's not normal is that, if it's an addition of angles, well, the identities is actually showing a subtraction. Okay, is actually showing a subtraction. So if it's a difference of angles, the identity is actually showing an addition. Okay, so that's how I get to memorize these. And I will tell you this too. These identities, just like the ones with Pythagorean identities, the more you write them, the more you use them, it gets better with your memory. If you don't use it, if you wait until the night before the quiz, the test to memorize them, well, good luck with that. I don't suggest that approach at all. So what I would like you to do is just to do these problems on a daily basis and just do them. And you just tell yourself that, oh, it's easy. It's something that's knowable. Okay, you can put it into your head. For sine function, okay, for sine function, the addition of angles, well, it's still addition right here. That's normal. What's kind of not normal, confusing, is that you have to do sine A cosine B and then cosine A sine B. Okay, so just a little bit of switch. And the other reason I'm not a big fan of this topic is because the proof, it's quite complicated. Okay, so we're not going to use it a lot after this chapter, after this topic, and the proof, it's quite complicated. So that makes me want to just get over with these materials as quickly as possible. I wish this week would pass by like this. And for tangent, all right, so the numerator is normal. Okay, if it's an addition, that's addition right here. But then the denominator, it's always the opposite sign, okay, of the numerator. So again, the sign right there, they would match, okay, the numerator and the numerator's sign would match with the actual addition or subtraction, but then the denominator is always the opposite. So today, you basically would have this piece of paper, this list, this chart for you to make reference from. Tomorrow, I would say, try to get these memorized by tonight. Tomorrow morning when you come in, I'm going to give you a piece of paper and you write down all these things. I mean, you have to do it one way or the other, sooner or later. So let's do it sooner rather than later. Okay. So let's go ahead and take a look at this. So we are going to look at this. We're like expressed in terms of sine, cosine, or tangent of one angle. Okay, one angle only. So we look at this look right here. We say, well, what does it look like? And we say, it looks like a sine, and it looks like an addition of two angles. So you identify your angle A and angle B. So we say, oh, that's just the same thing as sine of 70 degrees. Okay, so this is just a little taste. Okay, and then the next one, well, if it's see the cosine right here, so I can tell it's a cosine and subtraction. That means it's actually an addition. Okay, so I got my identities memorized, so I know. So since you don't have these identities memorized, so you have to look at the table at the very top. And then you have to actually add those two angles together. So that's why I said about your ability to handle fractions. So the common denominator, it's 12. So you got 3 pi and 4 pi up top. So you would have cosine of 7 pi over 12. Okay. All right, tangent. Tangent's very obvious. And as I said, it's very normal. Okay, so you look at the numerator, that tells you what the sign is. Is it addition or subtraction? And this one is showing you a subtraction. So you know this is a tangent A minus B. So you have tangent of 6 pi over 9, which you can reduce it to 2 pi over 3. Hey, what is tangent of 2 pi over 3? Negative root 3. Okay. All right. So that's just a little taster. Okay. Appetizer. So now let's go to the entree. The entree is this. Okay. So the entree is like, hey guys, we have this sine of 105. Can we do sine of 105? No, we cannot do it normally. We know how to do sine of 120 degrees. We know how to do sine of 135 degrees, but 105, we're like, do we use a calculator for that? Well, if you can come up with a sum to make this happen, what will be the two angles? Angles that you know very well. So you're like, oh yeah, I know this. 45 plus 60, 45 degrees plus 60 degrees is 105 degrees. And based on this, we're like, oh, now we don't need a calculator, because now we can say sine of 45 degrees cosine of 60 degrees plus cosine of 45 degrees and sine of 60 degrees. So if I have to say, oh, what's the beauty of this topic? It would probably be that, hey, we can use a brain instead of a calculator to find out something like this. But I would tell you that usually we don't. It's very not practical, so, but it's a skill. Okay, it's what calculator does actually. So so we say what now, and this is the part. Please do this. Okay. So in each pair of parentheses, you will put in the values. So sine 45 degrees would be. Now, I do hope that this is a very streamlined process. And you can also do it flawlessly. Wait, hold on. Nope. There's a flaw right there. All right. So what's the these two multiply together? What do you get? Root 2 over 4. And this is root 6 over 4. Now, earlier I commented, okay, on the difficulty level. And I said that if you know how to handle fractions, it's good. Now, and this is the part, and I would say this is the time, okay? If you have any wild thoughts about fractions, this is a time to either confirm it or kill it. Like if you feel like, wait, hold on, do I do cross multiplication? Then this is the time to ask yourself, do you know what cross multiplication is? Do you know when to do cross multiplication? If you still are, if you're still somewhat doubtful about what to do with the denominators, this is a time to clear things up, because I would expect that everyone should know how to handle these fraction stuff. And also, in addition to fractions, hey, do you know the square roots? Do you know how they handle square roots? If they have the same root, then the number underneath the roots, they can multiply together. All right. So that's the answer. Okay, so that's why I kept telling you guys got to know all those unit circle values. If not, you're going to cry again and again and again. Yes. Well, that would not be square root of h. That would not be square root of h. Okay, because they're not. No, you cannot add the numbers underneath the root together. Now, if you say, all right, Mr. Chan, I got a question. I confess that I'm not very good with these square root stuff. Is there a way that I can make myself more clear about these root stuff? Now, if you share the same kind of sentiment, I would say to you, I would say, yeah, let me give you a way out. Let me give you a way out. And the way out is this. What's square root of 4? So that's something you know already. So you can go ahead and set yourself some situations. Try it out. If you wonder, hey, can I multiply those two numbers together? Well, try it. Because you know this is 2 and this is 2, so the answer should be 4. So if you actually multiply the numbers together underneath the square root, you get square root of 16, which is 4. So that's true. Now, next thing, it's what about square root of 4 plus square root of 4? Can I add the numbers together? Well, you know this is 2, and 2 plus 2 is 4. But if you somehow add those two numbers together, you get square root of 8. And we asked the question, is square root h 4? And we said, no, that's not the case. So that's how you prove yourself that you cannot add the numbers underneath the root together. I would say these kind of questions, well, you either force yourself to memorize it, or you actually find a proof for it. Okay? We're good? All right, so let's go to the next page. Let's go to the next page. Okay. So now we're going to see things with these, denominator of 12. We've never seen denominator of 12. So I'm going to teach you how to handle this kind of situation. Now, if it's a power over 12, it's very likely that you have a subtraction. So the question is, well, what would the numerator be? What number you would write here? So think about this. If you're after subtraction, you're only getting a pi. And yet, these two fractions must reduce to a fraction with a denominator of either 3, 4, or 6. What would the subtraction be? 4 and 3, okay? 4 and 3 would be a good choice. Anyone without a suggestion? You can also do 3 and 2. Okay, that works too. Right. So you have options. You have options, and as long as it can be simplified, so it's all good. So you are actually seeing pi over 3 minus pi over 4. Okay. And once you have this, you may go ahead and write the, or use the identity to find out the value without using a calculator. Okay, so that's an option. We'll just go ahead and use gray color to illustrate this option. Actually, let me do it here. All right, so again, that's my usual practice. I want to make sure that it's compartmentized for all these terms. So I'm not making any mistakes here. So you probably would see a lot of fours in the denominator. So you have square root 2 plus square root 6, and then all over 4. Done. So I would tell you that if you have what do you have here? If you have sine and cosine, it's very user friendly. But if you have tangent, then you have to embrace the challenge for tangent. So now we're like, okay, so what about this one, tangent? So a tangent of 11 pi over 12. So you can think about addition and subtraction, but they must both have 12 in the denominator and some sort of pi in the numerator. So open for suggestion. Any suggestion of what should be added here to get you 11? Well, you have to have an odd number, right? 6 and 5. That's a good suggestion, but that's a problem. The problem is 5 cannot reduce with the 12th. So you can't really do 5 pi over 12 with those unit circle values. What else? Huh? 9 and 2, that works. 9 and 2 works. Any other suggestion? 8 and 3 will work. Okay. So if you look at addition, so you have a bunch of options here. Okay. So I'm gonna say I'm gonna stick with this. So I'm gonna simplify this first. So I would have 3 pi over 4 plus pi over 6. Yes. Okay. And I will go ahead and do my identity. So again, the more you write, the better it will be for your memory retention. Okay, so that's why after pre-calculus, students should be ready for calculus, because you have to practice all these fundamental skills day after day. All right, what's tangent of 3 pi over 4? -1. Tangent of pi over 6? Root 3 over 3. And then 1 minus. Now, what I've seen a lot in the past is that students may not realize that they are multiplying here, or they thought they knew, but then somehow they did something else. So we just reuse these values here. So that's a benefit of doing tangents. So because it stays with tangent, there's no sine and cosine right here. So now be very careful on how you handle the values. So the denominator would be 1 plus √3/3. So now, I think we did something like this back in the first semester. So we got complex fractions right here. How can we not have a complex fraction? How can we get ourselves out of this complex fraction situation? Now, if you multiply by the conjugate, that would get out of the that would get the square root out of the way, but you still have a complex fraction. You're going to multiply by the common denominator, which is 3. And when you distribute, you will see the elimination of the little denominator inside the complex fraction. So the numerator will become -3 plus √3. And then you've got 3 plus √3 right here. So now you don't have a complex fraction problem, but now you have a square root problem in the denominator, and now you have to do the multiplication of the conjugate. Now, by the way, I'm not sure if you see it here. This thing right here, do you know that it can be written as -3 minus √3? Okay. Because you see something that's quite similar, and I want to make sure that you can see it. So what is the final answer? Well, not yet, still a couple of steps away. So in the numerator, you have a negative of 3 minus √3 squared. And the denominator would have 9 minus 3, which is 6. So I think that would definitely fuel your dislike toward this topic. All right. So again, if I could apologize, I would apologize. I apologize that you have to go through this, but hey, just look at this as a little training of your fundamental skills. Well, that's really what you can do. We would not need to square the binomial because that actually is more simplified. You write less. And as a practice as in practice in math, and also next year in calculus, we tend to keep things in factored form. Whenever we can factor, we factor. I think that should resonate a lot from the verification of those trig identities. The simplification, you always simplify. You always factor. All right, so which one's more difficult? I'm going to do the second one with you, okay? And then you can spend more time to practice it. So for this one, all right, so I'm going to verify. I'm going to touch on the left-hand side right here. So the left-hand side right here is the difference of two. The difference of two angles, okay? Cosine of the difference of two angles. So I'm going to write down cosine of 5 pi over 4, cosine of x plus sine of 5 pi over 4 and sine of x. And what you have here, it's negative √2/2 and also negative √2/2, which means that you can factor out the negative √2/2 from both terms. And what's left? It's just that. So a good thing about this is that it doesn't really take much to think. They give you the difference of angle, then you know what identity to use, and just use it carefully. Just make sure that you get all those unit circle values right, and that's all. Okay. So yeah, I would suggest you to go ahead and do them for the worksheet. Question 4 through 7. I'm not sure if you have enough space. I don't think you have enough space because you have to do sine, cosine, and tangent all in the space below. And if you do tangent, it's going to eat up a lot of space. So you might want to work on these questions on a piece of paper for your practice. Yeah. So yes. So just to recap, this week it's all about these new identities. Digest them on a daily basis. Okay. You can download this on Schoology. Okay. You want to quiz yourself. Okay. On all these. Today and tomorrow will be summing differences, and then Thursday would be double angle and half angle. But the quiz is, I believe, the quiz is only on sum and difference. Let me double check. Term 3 calendar. By the way, we have an updated calendar. Okay. So if you look at the calendar right here, it is sum and difference, double angle identities for this Friday's quiz. So if I were you, I would get these identities stuffed into your head so that you won't have to worry about cramming all these the night before. Okay.